Hey guys, welcome back to a new video. So let me just share my screen. Yep, I guess it's visible. So let's start today's question, which is threesome. Let me just open. Okay, I've already opened this. Yeah, so before starting the problem, if you haven't subscribed the channel, please consider subscribing. And also, I have created a playlist of all these questions, so you can consider checking those all questions. So let me just read the question. So the name of the question is threesome, and given an integer array nums, written all the triplets like this I, j and k, nums of I, j, k, such that I is not equals to j, I is not equals to k, and j is not equals to k, like yes, and nums of I plus nums of j equals to 0. Okay, so this means no two index will have same values, like all these have different values, and all their sum will be 0. The solution must not contain duplicates triplets, so we don't have to find duplicates value, we have to find only unique these values. So these values are like these elements only, not the index. Yeah, so we have solved previously. If you haven't watched all these video, I have already solved two sum problem. It's kind of similar to that. And also yesterday we solved this two sum input sorted array. We are going to use this solution as well to solve our threesome problem. So what we will do is we will divide our threesome problem into sub problems. So one that problem will be going to solve this two sum sorted array problem. So yeah, and these are the inputs be like, yeah, so the brute force solution will be nq, I guess. And yeah, so that you can check out from the discussion tab, or you can just search for it. Let's solve the n square problem. So yeah, so this two sum, if you seen the yesterday problem, this two sum problem depend on the sorted array. So to convert this, we have to sort the array first. So sorting the array will not change our solution or resulting answer will in any way. So we can sort this, and the time complexity of a usual sort function is n log n. So yeah, let me just sort this first. So sort this nums of, let me write the solution first, then I will explain you, because explaining this is quite like difficult without the code. So let me just first write the code, and then I will explain you everything. For now you can just think of like we are subdividing this threesome problem into two sum problem for sorted array. So yeah, so this should be begin, and this should be nums dot n, so that will sort this into n log n. And let me just calculate n as well, which will be nums of size. Let me check if it is recording. Yes, it is. And then we need okay, we need a for loop that we are going to start from 0 to n minus 2. So why n minus 2, why not n? So since we are going to file the triplet and we are going to run this for two sub problem, so we will only check like this. We will only check till now this, not this, because here we are not going to get 1, 2 and 3 triplets. So till now we are going to get triplets from this, including this 1, 2 and 3. So at max we are going to go from till 0, from 0 to till n minus 2. So this is n minus 1, and this is n minus 1, and this is n minus 2. So that's why it is n minus 2. Yeah, so this means smaller than this, so we are going to at most we our I will go till now. So this is n minus 2, and our I will from go from 0 to n minus 2. So yeah. Yeah, so let me just write here low, which will be like nums of I minus 1, I plus 1, and high will be nums of n minus 1, that is the last element. Then so this will, we have divided our solution here into sub problem. These high and low, if you have watched the previous video, will be for the two pointers for sub or to some problem. So while low is smaller than high, then there will be sum. So sum will be like nums of I, the current value, and then let's say this is the current value. Then we have to solve the sub problem for two sum. So the current value and then the rest two sums will be the low and high. So let me write the low, nums of low plus nums of high. Then we have to check if sum equals to 0. So all will add up to 0. So that's why we have to check 0. If it is 0, else if, so these three conditions will be there. Sum is smaller than 0, else sum is greater than 0. If sum is 0, that means we find our one triplet that end up summing up in equals to 0. So we should have a answer vector in this format, vector into vector, as in this format, vector inside vector, that is 2D array or 2D vector answer, and we are going to return this at last. So let me write here. And now if we find a triplet, we just answer dot push back the values of these triplets. So that will be nums of I, nums of low, and nums of high. So that's that. Otherwise, since is as I told you in the previous question, you can watch out that definitely. So now the sum is greater than smaller than 0. So we have to increase. This is sorted. Now let me just sort it so that you can better understand. So after sorting, this will look like this. So this will be -1, and this will be 0, this will be 1, this will be 2, and the -4 will go at very first. Yeah, so let me just check. -4, -1, -1, 0, 1, and 2. Okay, so after sorting it, it's look like this. So if the sum is smaller than 0, so if we are, let's suppose we are summing 2 and -1, so that or let's say this 0 and -1, let's suppose we are summing this 0 and -1, the total sum will be -1, which is smaller than 0. So we have to increase this index, which is a negative index or the smaller index. So we will increase this. Then also it is the sum 0, sorry, -1. Then we again increase the smaller index, and then it will be 0. So when the sum is 0, smaller than 0, so we have to increase our left index or low index like this. Otherwise we have to increase our high, decrease our high index. So yeah, that's that. And in this case also, if we find here, we have to increase our high, low, and decrease our high. Okay, so that's will be like this. And also we have a condition that we have to also check for. If that condition is not there, this is the answer. So we have to incorporate that condition also. That condition is these cannot be same, and the values also cannot be same. That means, so no set must not contain duplicate triplets. So for that, one condition we have to put is like this: if I is not equal to 0, that is first index. We are not at first index, and nums of current value equals to nums of the current previous value, I minus 1 value, are equal, then we have to continue, because we have already calculated for this nums value if they are same. So we will continue, we will not calculate for them. So in this way we can escape a repeating character here, for example this minus 1. Now the same condition we have to follow inside also, because here it is a separate while loop running from low to high, as you can see. So for that, what we have to do is, after we have find one solution, we have to skip all the repeated or duplicate elements. So for that, while low is smaller than high and nums of low equals to nums of low minus 1, then we have to increase our low plus plus. And also while low is smaller than high and nums of high equals to, so this should be not low minus 1, this should be low plus 1, the next value. Then that's why we are increasing plus plus. And here it will be like, because we are iterating from back, so this pointer is iterating from back, so that's why it is like, so from back the next value is minus 1, and from, if we are iterating in front, the next value is plus 1. So yeah, so it will be like high minus 1. If they are equal, then we have to increase our high, decrease our high. So yeah, yeah, so just run this and see if it works or not. We have to check. Yeah, it should be nums, not nuns. Answer dot pushback. Here it is a answer vector, and here answer dot pushback. Yeah, so this should be not these values, this should be a array of values. And so much of silly mistakes there. Okay, so this is a weird thing. Let me just check from very starting. Nums dot begin, nums and n is this, and high is, oh okay, so this should not be nums of I, it should be I plus 1 and n minus 1. These are the index, not the actual values. Yeah, so this is working for this case. Let me submit and check for other cases as well. Yeah, so it's working. So that's about the solution. Let's just revisit this solution and understand why and what we did. So we sorted the array to use the fact of our this solution of twosum with input array sorted. So that's why we sorted the array, and the time complexity of sorting is n log n, and we can't solve this problem without with lower than n log n or equals to n log n. So we can use this sorting here, and because we have to use the fact of sorted array to some problem. So yeah, so now what we are doing is, after sorting it, this array will look like this, and then we are starting from the first element. So the first element will be nums of I, and then what we are doing, we are solving the twosum problem for the remaining array. So twosum here will like this. If we like for the rest of the sum, it will be like minus 4, or the like additive inverse of minus 4, that is plus 4. So we are finding here all these triplets equals to 0. Now that is our sub problem. We are doing from high low to high, and low is like escaping this or starting from the next value, so I plus 1, until the very end. So high will be n minus 1. And why we are doing this from I to n minus 2? Because we have to find triplets. For that we need all we need at least 3 values inside, so that's why we are doing it till n-2. Yes, and so that's about this. And then this is simple to some sorted problem here, and these are these conditions which are like removing the duplicacy of, if I just let me just remove these values, and let's try to submit this. uh, yeah, it will work for this case. Let me just submit it. Yeah, so as you can see, we are getting these duplicates, and it is only required single value, so that's why these conditions are there. Otherwise simple to some problem with the sorted. Yeah, so let me add the condition back here. So yeah, so now let's calculate the time complexity. The time complexity will be like this. Since it is n square, sorry, this is of n, and this is also n, and this is inside this, so it will be overall n square. So let me write the time complexity. Time complexity equals to, pardon me for the spelling, n into n. Yeah, and space complexity, are we using any space? Yes, we are using space. It will be used here while sorting, so it will be like of n, I guess, extra space. Yes, so while merge sort they create sub arrays. Yeah, so we can consider this as extra space, and this is the answer itself, so we will not consider it as extra space. Yeah, so that's about it. If you like the video, please consider subscribing and liking the video. And also, if there is anything you want to ask, you can write down in comment section, and you can tell me how can I improve further. Yeah, so that's about it. Let me just check this, and also we are going to solve this tomorrow. Yeah, and you can follow along all this. I created the playlist. You can just open my channel. Let me just show you. Yeah, so these are, I guess, all these videos, and I've created a playlist for this. So yeah, thanks for watching, and I will see you in the next video.